I'll wait for this to start. Okay, so what we're going to do here, we're just going to do a quick review of everything we did with permutations. So this first slide is just everything we've done in this unit so far. And then in the next part of the lesson is we'll get going into the second half of this unit, and then we'll call it good. So we've only got 2 lessons left, and then we're done the unit. Okay, so it says Manny, love the name, is the captain of a 15-member soccer team that has won its city championship. How many ways can 3 players line up to receive the championship trophy? So this is a permutation because if the order of the players matters, okay? Because they're like getting a picture taken or whatever. So how many blanks do we draw? 3. So how many choices do you have for the first position? How many players? 15. Then 15. Now, if you wanted to use NPR, you've got 15 players and you are arranging 3 of them. Those 2 things mean the exact same thing. Okay, how many ways can Manny and 2 other players line up to receive the championship trophy if the captain must be first in line? So remember, Manny is the captain. So still 3 players lining up. But Manny has to be first because he is the captain of the team. So how many Mannys do we have? 1. So once we line up Manny, how many players do we now have left to line up? Then 13. So if you were doing this through NPR, you would go 1 times 14p2. And 1 times anything doesn't affect anything, so it's just the 14p2. Okay? Okay, consider the word equation. So Scrabble tiles. Okay? How many different arrangements, so again, because it's arrangements, the order matters, all the letters are used. So how many tiles do we have in front of us? 8. So there's 8 tiles. You're going to use all 8. So option number 1 is to write 8, 7, 6, 5, 4, 3, 2, 1, because you're going to use all 8 tiles. Or you could go, you know what? I automatically, this is going to be 8, 7, 6, 5, 4, 3, 2, 1. Or you've got 8 tiles, and you are arranging all 8 of them. Either one. Okay, next one. All the letters are used. So again, still 8 blanks. And Q and N must be placed together. So when you see the word together, this is that formula that you have to have memorized. So you're going to stick the Q and N together. So those Scrabble tiles now become 1 tile. So your other tiles are, so these are all your tiles. So the way you do together questions are, you stick whatever you need to together. And then you're going to come up with your new total. So what is your new total? 1, 2, 3, 4, 5, 6, 7. So you go 7 factorial. And then you times it by how many items you put in the box. So 7 factorial times 2 factorial. So you have to have that formula memorized. So duct tape your tiles together, and then you go new total times by the number of things in the box. How many 5-letter arrangements can be made? If it must start and finish with a vowel. Okay, so how many blanks does this one have? Not 8, but 5, yes. So it has to start with a vowel and finish with a vowel. So how many vowels are there in equation? 5. We've got the E, the A, the I, the O, and the U. Oh yeah, that's cool. Okay, 5. So you've got 5 choices for the first vowel. Let's say you pick the letter I. And then you've got 4 choices for the next vowel. Let's say you pick the U. So now how many Scrabble tiles do you have left to pick from? Remember, you originally had 8. You've placed 2. So how many Scrabble tiles are left? 6. So you go 6, 5, 4. Okay. Part D, how many arrangements can be made if the consonants cannot be together? Okay, so this is another one that you need to memorize. Okay, so the not together questions, how you do them is you go no restrictions minus the consonants are together. So the way I worded it in your notes was no restrictions minus the opposite. So consonants are together. So we're going to go back and we're going to go here and we're going to assume all 8 letters are used again. Sorry, I should have said that in the question. So we're going to use all of our 8 tiles. So how many ways are there of arranging 8 tiles? 8, 7, 6, 5, 4, 3, 2, 1. So 8 factorial. If the consonants are together. So how many consonants do we have in equation? Q, T, and N. So we've got 3 consonants. So we've got Q, T, and N. We're going to stick those together with duct tape. So I've got E, Q, U, A, T, I, O, N. So what is my new total? 1, 2, 3, 4, 5, 6. So my new total is 6 factorial times by the number of things in the box, 3 factorial. So on your calculator, you would go 8 factorial minus 6 factorial times 3 factorial. The together, not together questions, they are the hardest ones you're going to do because you have to have the formula memorized. It's not on your formula sheet. It will not be given to you on the diploma. Okay. Now, is a together, not together question guaranteed on your diploma? No, it's not. Okay. But if it's there, the only way to do it is with that formula. Okay, new concept, number 3A. How many arrangements, so again, arrangements mean permutation, permutation means blanks. How many arrangements are possible using all the letters of the word algebra? So how many Scrabble tiles? 7. So 7 factorial. Have you missed anything? Remember, you on your back of your mind, you always have to be thinking about identical objects. Do we have any identical objects? Yes. We've got 2 A's. So whatever your identical objects are, we divide by that. So it's 7 factorial divided by 2 factorial. So again, the question will not tell you, hey, don't forget, you've got 2 A's. You need to remember to be looking for that. For part B, how many arrangements are possible if the vowels and consonants alternate? Okay, when you do one of these questions, the repeats will always be in the denominator. It doesn't matter what the question's asking. If you've got identical objects, the identical objects always go in the bottom every single time. Like every single time. So for the numerator, again, we're using all the letters of the word algebra, which is 7 letters, and vowels and consonants alternate. So how many vowels are there in algebra? 3, A, E, A. And how many consonants? There's 4, L, G, B, R. So what order does it have to go in order to make it alternate? It has to go consonant, vowel, consonant, vowel, consonant, vowel, consonant. That's what alternate means, right? Consonant then a vowel, consonant then a vowel. And it has to go consonant first because there's more consonants than vowels. So let's do the consonants first. How many consonants do you have? 4. So you got 4 consonants, and then what will you have for the next one? Then 2, then 1. How many vowels do you have? Then. So there's nothing stopping you on your calculator to plugging that in exactly like that. Just make sure that you use brackets before you go divide by 2 factorial. However, if you did want to make your life a little easier, if you look at the yellow, yellow goes 4, 3, 2, 1. So for the yellow, I can go 4, 3, 2, 1 is 4 factorial. For the green, it goes 3, 2, 1. So 3 factorial. And then you divide by the 2 factorial. So that is everything we've done so far in the unit. Okay? So we've done basic permutations, permutations with restrictions, together, not togethers, and repeats. The only thing that's not on there is a pathways question, which is what we did the other day. Okay? Questions on that? Okay. So let's look at combinations and see how they compare to permutations. So it's a subtle thing, but it means a lot. A permutation is an arrangement. And when you arrange things, the order matters. Like if I were to line you up for a photo from shortest to tallest, and I were taking your picture, that would be a different photo than if I were to say, just line up in any order that you like. It doesn't matter that it's the same people, it would be a different photo because you're lined up differently. Okay? So that would be a permutation because I'm arranging you into different orders. Okay? A combination, on the other hand, is a selection of things where the order has no importance whatsoever. So if I needed Morgan, Reese, and Abby to stand up here at the front of the room, it doesn't matter if I say Morgan, Reese, Abby, get on up here. Or if I say Abby, Reese, Morgan, get on up here. It's the same 3 people. I'm selecting you. I am not arranging you. Okay? So here's the tricky part to this unit. So for today and tomorrow and Monday, all the questions will be selections. So you won't even have to think about it. It's just going to be an automatic selection. On Tuesday, I'm just going to start hucking random questions at you. So I'll give you a permutation, then a combination, then a combination, then a permutation, then another permutation, another permutation, then a combination. And I'm just going to keep going. So you're going to have to look at each question and go, is that a blanks? Is that a together? Is that a repeats? Or is that a combination? So with every single question, you're going to have to go through that thought process in your head. Okay, and that's the worst part of this unit. Now, in terms of how we do combination questions, they are ridiculously easy to do. Ridiculously easy. So it says here, suppose we have to form a number a number consisting of 3 digits using 1, 2, 3, or 4. To form this number, the digits have to be arranged. Different numbers will get formed depending on the order to which we arrange the digits. This is a permutation, right? Because the order matters. Okay. So again, when it talks about arrangements, arrangements are permutations. Okay, so on the diploma, you'll typically see the word arranging or you'll see the word selecting. Selecting is combination, arranging is permutation. Okay, so on this one, it says, now suppose that we have to make a team of 11 players out of 20 players. This is an example of a combination because the order of the players in the team will not result in a change in the team. So if let's say this classroom was full, all 30 desks were full, and I just needed you 1, 2, 3, 4, 5, 6, 7. I needed you 8 off to the side. It doesn't matter which order I pick the 8 of you, as long as I pick the same 8 kids, it's the same group. That is a combination because all you're doing is selecting. Whoops. All you're doing is selecting, and the order does not matter. Okay? So a permutation is an arrangement where the order matters. A combination is a selection where the order doesn't matter. Okay? So if you go into your workbook, this is page 96 for me, please. Okay. So it says here 5 students, Al, Byron, Colin, Dave, and Eric, take part in a cross-country race to represent their school. Fair enough. The winner is going to get $50. Runner-up gets $25. Third place gets $10. Definitely not enough money to make me want to run. But anyway, the table shows all the possible ways in which the 3 prizes could be awarded. So A stands for Al, B stands for Byron. Okay. So what we are going to assume is that if the A, whatever is in, right, what you're assuming is that. So ABC means Alan gets the $50, Byron gets the $25, and Colin gets the $10. Whereas on this one, Byron gets the 50, Dave gets the 25, and Colin gets the 10. So in this example, is it a permutation or a combination? Does the order of the letters give you a different result? Yes. So this is a permutation because the order matters. ABC is not the same as BCA, and it's not the same as CBA. Like all of these, do you see how all 3 of those use the same letters? But they each mean something different, right? Because the order of the letters matters. So how many ways are there to award the 3 prizes? Well, 1, 2, 3, 4, 5, 6. So 60 ways. You could have also said, I've got 5 people. I'm arranging 3 of them. Or you could have gone 5 times 4 times 3. There are 5 choices for first place, 4 choices for second place, 3 choices for third place. They all give you out 60. Okay? Nothing brain shocking there. So the next example, for participating in the cross-country race, the school has been awarded 3 places at a running clinic. The school coach decides to select the 3 lucky students from the ones who took place in the cross-country race. Okay, so here's the key to this. So that coach has to select 3 kids from those 5 that ran in the race. So, do you understand that this means he selected players A, B, and C? They all of these say the exact same thing. Al's going, Byron's going, and Colin's going. What does this one mean? This one means Al is going, Byron is going, and Dave is going. Does the order to which they're selected matter? No. So this is a combination because each one of these columns is saying the exact same thing. Like this column is saying Byron, Dave, and Colin get to go. This column is all saying the same thing. Byron, Dave, and Eric all get to go. So I don't need all of this because they're all saying the same thing. So how many ways can you select 3 guys from 5? 10. So how do we do that? How many players are we picking? From how many? So the way we write it is 5C3. And you can either think of the word C as standing for combination, or you can think of the C as meaning choosing. So you're choosing 3 players from 5. Okay? That's it. So all of these questions, this is all you have to do. That's it. There's no together, not together questions. There's no repeats. There's none of that. It's just NCR. Okay? We're not going to worry about this. Okay, so on your, let me just get out my booklet here just so I know that my page looks the same as yours. Okay, so at the top of your page, on page 97, you've got this formula. So NCR, so N is the total number, and R is the number that you're selecting. Okay. So on your calculator, you hit math, you go over to prob using your arrows, and you pick number 3 for NCR. Okay. Now the calculation that your calculator is doing is this. You don't need to know this calculation. That's what your calculator is doing. Is it's taking the total number and factorialing it, and then dividing it by the number you're selecting factorial times by the subtraction of the 2. You don't need to know that for 30-2. You just need to know how to push it into your calculator. Okay. But on your formula sheet, they do give you the formulas. Okay. And the reason for that is if you forget where to find the button, you could punch in, so that 5C3, so that question that we just did, you could go onto your calculator and punch it in and get out the same answer. But here's the thing. If you know where the factorial button is, do you automatically know where the NCR button is? Yes. Finally, so that last question, we had 5 players and we're selecting 3. This is a perfectly acceptable way of showing the answer. The other way of showing the answer, this is just shorthand, is you do big brackets and you write the 5 on top, the 3 on the bottom, but you don't put the line in the middle to make it look like a fraction. It's weird because 30-2 kids are expected to know that notation, but 30-1 kids aren't. It's kind of weird. But yeah, so if on your diploma you see this or this, they mean the same thing. Okay. 99% of kids are going to write this. And on the last diploma, this is the only one that I saw. Okay, but just so that you're aware, this means the same thing. Okay, let's just do some examples. You're going to find this isn't hard. Okay, remember I said the permutations is the much harder part of this unit. Okay, so So 3 students from a class of 10 are to be chosen to go on a school trip. Yay. In how many ways can they be selected? So again, you're selecting these kids. You're not lining up the 3 kids for a photo. You're simply selecting them. So how many kids do you have to pick from? Do you have this one? Okay. Okay. How many kids do you pick from? And how many are you choosing? Nope. 3. That's it. So you just punch that into your calculator. Like that's it. So understand that on the diploma, the A, B, C, D could also look like that, but they mean the same thing. Okay. So again, you would just punch that into your calculator. So the way I do it on my calculator is I punch in 10 first, okay? And then I hit math, then probability, and then I pick number 3, and then I pick 3 for the R. So there's 120 different groups I could select. So this is where you're going to go, whoa, there's 120 different groups I could select and I only have 10 kids to pick from? Yes. These answers are going to feel way too big for the scenario, but you just got to trust the process. Okay. All right. We talked about this question yesterday, but let's just give it a go. So to win the Lotto 649, a person must correctly select 6 numbers between 1 to 49 inclusive. Inclusive means including 1 and 49. Exclusive would mean you wouldn't be allowed to pick 1 and 49. Okay. Oh, okay. Okay. But inclusive just means includes 1 and 49. Okay. It would mean that you couldn't circle 1 or 49. Yeah. So in other words, your choices would be from 2 to 48. Yeah. And again, I've never seen that wording on the diploma, but wonders never cease. Okay. Jasper selected the 6 numbers, selected the 6 numbers from the birth dates of his family. So 3, 7, 9, 11, 20, and 29. How many different selections of numbers could he have made? So what this question is saying is that how many actual ticket possibilities are there? Okay. So how many numbers do you have to choose from? Choose from. And how many numbers are you choosing? Okay. So let's punch this thing into our calculator. So if I go 49, math, probability, choose 6. So there is just shy of 14 million combinations of numbers possible. That means in Canada, not quite every other person has to buy one ticket. So every other person in Canada, so half of Canada's population, would each have to buy a ticket, each with a different combination of 6 numbers in order to guarantee a win. Now, if we talk about odds of winning, your odds of winning are 1 in 14 million. 1 in 14 million. Okay, somebody whip out your phone for me. Type in odds of being struck by lightning. So what are the odds of being struck by lightning? 1 in 15,000. Okay, so 1 in 50, they don't have everything going bad for them down there. Okay, so you have a 1 in 15,000 shot at being struck by lightning. You have a 1 in 14 million shot of winning the lottery. Mathematically, what that means is you are 1,000 times more likely to be struck by lightning than you are to win the lottery. Or in other words, you could be struck by lightning 1,000 times before you ever win the lottery once. Exactly. You just glow for a few years. Okay? So this isn't part of it, but the other big lotto out here is Super 7. Super 7 is the numbers 1 to 50, and you have to select 7. So the average person thinks, well, it's the same thing, right? They added one more number, but I also get to select one more number. Is it? Plug it in. And then just read off the digits to me. No, another 4? Okay. So your odds of winning Super 7 is 1 in 99 million. That means every man, woman, and child in Canada would each have to buy 3 tickets, and each ticket would have to be a different combination of numbers to guarantee one of them wins. This is why the lotto jackpots grow the way they do. Because what happens with lotteries is that if everybody, they take how many tickets you bought, how many sold, that's what creates the jackpot. If that jackpot isn't claimed, they then take that money and then they add to it the next set of tickets that get bought. That's why the jackpot grows. That's why Super 7's jackpot is always substantially bigger than Lotto 649's jackpot. Because the odds of winning the Super 7 are much, much less than the odds of winning Lotto 649. You're still better off to swing a golf club in a lightning storm than hold all your eggs in a basket. Like, look, do people win the lottery? Yes. They have to. Statistically, you have to. Somebody's got to win. And do you have any hope of winning if you don't buy a ticket? No. And that's where the gambling piece comes in, right? That's where people buy tickets because, like, well, somebody's got to win. You're right. But the odds of it being you are not very likely. But it still could be. It still could be. But this is not a retirement plan, right? Go, well, I'll just win the lottery. That's my retirement. Again, you have better luck of winning a golf club in a lightning storm than you do winning the lottery. Okay? Okay. So now typically the diploma usually doesn't have lottery questions on there because they don't want to induce gambling in you. So most of the time, the questions that are on the diploma are these types where it talks about committees and subcommittees. Okay. If you get overwhelmed with words, I strongly recommend you break out 2 highlighters so that you can keep track of the 2 sets of numbers that you've got going on. So in this question it says, the athletic council decides to form a subcommittee of 7 council members to look at how funds raised should be spent on sports. There are a total of 15 council members. Okay, so you've got 15 council members, and you're going to create a subcommittee of 7. I'll give you your break after we've done this question, okay? So now, of that 15, we've got 9 guys and 6 girls. Notice 9 plus 6 is 15. Okay? So here's the restriction. The subcommittee has to have 3 females on it. Okay? So here's the catch to this. And again, I'm not trying to turn this into something political. I promise you. But in this context, you can either only be male or female. Okay, I'm not making a political statement here. I'm just stating a fact for this question. You can either only be male or female. Okay, so if the committee has to have 3 females on it, what is the assumption regarding the other 4 positions that have not been filled? They must be male. So with these questions, you do have to read between the line and create that scenario. They will, quite often with these questions, they'll only mention part of it. So you have to assume the other part. They can only do these questions where there's 2 options, right? Let's say if you've got a bag with red balls and green balls. That means when you reach into that bag and select a ball, it's either going to be red or green. There's no yellow possibility. Okay, that is what it is. So they might only mention about the red balls, but you can assume then the rest must be green. Okay. Okay, so in how many ways can the females be chosen? Can they be selected? So, NCR. How many females are you selecting from? 6. How many females do you want? 3. Do you understand that 3C6 makes absolutely 0 sense? 3C6 would mean you're selecting 6 from 3. Not possible. The first number will always be bigger than the second. Okay. How many ways can the males be chosen? Okay, how many males do you have to pick from? 9. And how many do you want? That was the assumption. In how many ways can the subcommittees be chosen? Okay, so listen to my words. On this subcommittee, does it have guys and girls or guys or girls? And. So we're going to go females and males, and means times. So we're going to take the number of ways of selecting females and times it by the number of ways of selecting males. And you would punch that into your calculator. And by the way, that is the worst part of these questions, is plugging these bad boys in. Okay, so on your quiz for me next week, this is all I need to see. You don't need to actually do the whole button push. Okay. So let's bring a restriction into this. In how many ways can the subcommittee be chosen if Bruce, now on the diploma, they will say the male football coach, because there might be a girl out there by the name of Bruce. We don't know. We don't know. So Bruce, the male football coach, must be included. So do you remember with permutations, we always did the restriction first, right? Same thing here. We're going to get Bruce out of the way. How many Bruces do we have? And how many of him are we selecting? 1. It's like saying the first person in the photo has to be Bruce. So there would be a 1 in that blank. Now, the committee is going to consist of Bruce and girls and boys. Okay. For my girls, do I still have 6 girls to pick from and I need 3? Yes, that has not changed. Here's where the change has happened. You've picked Bruce already. So how many boys do you now have left to pick from? 8. And how many boy positions do you still have left to fill? 3. All those questions that I just asked you out loud that you had no problems answering, that's the conversation you need to have in your head. You literally need to talk yourself through these questions, step by step, super slowly. Now, this thing will always have a value of 1, so you don't need to punch that into your calculator. You just need to punch this in to get out the answer. Okay? Would you say these are easier than permutations? Yes, just a little bit, until you get used to them, right? Okay. The workbook does a whole bunch of questions with cards. I didn't see any card questions on the diploma, and here's why. Um, in order to ask you a card question requires you to understand what a deck of cards is. And for you guys might be like, well, of course, have you lived under a rock? No, but somebody might be a refugee from Libya who's literally been in a war-torn country their entire life and they have not seen a deck of cards in their life. The questions on the diploma have to be fair game for everybody. So they typically stay away from scenarios where a middle-class kid from Tabor would have an unfair advantage versus a refugee coming from Syria. Okay? However, since the workbook has these questions in it, they are good questions to try. They get you practicing the idea. If you were going to put money on something on the diploma, it's probably going to be a committee subcommittee question. That is probably what you're going to get. Okay. Okay, decks of cards. 52 cards in the deck. 26 are black, 26 are red. Of the black are clubs and spades. Of the red, hearts and diamonds. There is 13 of each because 13 plus 13 is 26. 13 plus 13 is 26. Those cards go from ace, meaning 1, up to 10, and then jack, queen, king, meaning 11, 12, 13. Okay? The jack, queen, king are called your face cards. Make sense? Okay. Poker is a card game from a deck of 52 cards. Okay? How many different 5-card hands are possible? Okay. Why is this a combination? Because let's say we sit around in a circle and we have a game of poker. So not allowed to do that. But if we were, when you're getting your 5 cards dealt to you, what's the first thing you do with your cards when you get them? You rearrange them, right? So does the order that you got them matter? No, the order does not matter. So because the order doesn't matter, this is a combination question. So how many cards are in the deck? 52. How many are you selecting? 5. Okay. So part B says, in how many in the hands in A? This just means that you still have a 5-card hand. Okay. So in your 5-card hand, how many are all diamonds? So all 5 cards have to be diamonds. How many diamonds do you have in your deck? 13, right? You got 13 diamonds. So all 5 cards must be from those 13. So you've got 13 diamonds to pick from, and you need 5 of them. 4 black and 1 red. So first off, and means times. How many black cards are there to pick from? 26. And how many do you want? 4. How many red cards are there to pick from? And how many do you want? 1. Okay. How many kings are there in the deck? 4. And you want 3. How many queens are there in a deck? And you want 2. That's it. Don't overthink this. Okay? It's what now Mr. Hughes was telling me, instead of giving you the words describing a deck, what they have done in the past is actually put a picture on in the diploma showing all the cards in a deck. So they'll show like ace to king hearts, ace to king spades, so you can physically see, and you could go and go, how many kings there are? 1, 2, 3, 4. I have 4, I need 3. Okay. There's always a catch, right? There's always a catch. So there's a catch here. On each of these questions, I made sure that I accounted for all 5 cards with all of them. Look at the next question. All I've said is 3 kings. So remember, you got 5 cards in your hand. I'm saying 3 of them have to be kings. Have I said anything about the other 2? So what you have to do here is you have to think of this as saying 3 kings and any 2 other cards. Because you have to account for all 5 cards in your hand at all times. So how many kings are there in a deck? And you need 3. And, okay, so we've dealt with the kings. How many cards in the deck? 52. Remove the kings. How many cards do you now have left in your deck? 48. And you need any 2 of them. Because this is the kings. This is the rest of the cards. It's just like male and female. It's all it is. It's the same thing as male and female. We're thinking of kings and not kings. So what about this one? 4 aces and 1 other card, or in other words, not an ace. So how many aces in a deck? So we have 4 aces, we won all of them. Now, how many other cards are there that aren't aces? 48, and you need 1 of them. We're not going to worry about part 6. Yep. Yes, not 2 kings or 1 king, yes. And that's, so we're going to, so good segue. So on Monday, what we're going to do, so I was going to do this tomorrow, but I forgot to tell Kaylee that we were going to go on. So we're just going to have a work day tomorrow. On Monday, the questions will say, how many hands that could you create that have at most 3 kings? So that would mean what? 3 kings, 2 kings, 1 king, no kings. So you're going to go 3 kings or 2 kings, or, so you're going to go through and go, so this would be 4, this would be 3 kings, 2 kings, 1 king, no kings, and then you're going to do that. Now, if you're going, holy frictional, I have to plug that into my calculator, no. What they will do on the diploma, the answer will look like that. It will just be a list, and then part B, and then part C, and then part D. I did not see, I only saw 1 of these on the diploma, but it only had 2 things. You had this plus this. And there wasn't 4 things that you had to add. So it was, but the key is it's understanding what the word does at most 3 kings mean. If you understand what that means, it's just the same. Did you see how I just went 3, 2, 1, 0, 1, 2, 3, 4, 5? And then I just plugged in 48, 4, 48, 4, 48, 4, 48, 4. Because that's not changing. So that's what we're going to do Monday. Okay? So, are we done? We're done. So, on the assignment, don't do 9, don't do 11. Okay?